Hello everyone. In this video, I will continue talking about concrete mix design. In the last video, I talked about how to calculate the required average compressive strength FCR prime. And in this video, I will talk about how to determine the water to cement ratio needed to produce the required strength FCR prime. Historical records can be used to plot a strength versus water to cement ratio curve as shown in this figure. If the historical data are not available, 3 trial batches can be made at different water to cement ratios to establish a similar curve. And based on this figure, you can determine the water to cement ratio needed to produce a specific required strength. For example, if the required strength is 4.6 KSI, then if it's not iron entrained, the water to cement ratio should be a little bit more than 0.5. If it's iron entrained, then the water to cement ratio will be a little bit more than 0.4. The value of water to cement ratio should also be checked against the maximum allowable water to cement ratio value for different exposure conditions. In general, more severe exposure conditions require lower water to cement ratios. For example, as shown in this figure, you can find the maximum water to cement ratios for different exposure conditions. For example, if concrete intended to have low permeability when exposed to water, the maximum water to cement ratio should be 0.5. For concrete exposed to freezing and thawing in a moist condition or de-icers, the maximum water to cement ratio will be 0.45. For reinforced concrete exposed to chlorides from de-icing salts, salt water, brackish water, seawater, or spray from these sources, the maximum water to cement ratio will be 0.4. And in this figure, you can find the maximum water to cement ratio for the concrete exposed to sulfates in soil or water. And depending on how severe the sulfate exposure is, you can find the maximum water to cement ratio values in this table. Remember to always use the lowest water to cement ratio for all applicable conditions. For example, if you find, based on this figure, you find that the water to cement ratio should be 0.6. However, the concrete will be exposed to freezing and thawing in moist condition, then the water to cement ratio value should be lowered to 0.45. And if the concrete will be exposed to very severe sulfate exposure, and then the water to cement ratio should be further lowered to 0.4.